Hello, today's video is on 5.5, completing the square. Before we actually get started on the 5.5 stuff, we're going to go ahead and review 3 topics that you're going to need to know for the new material today. The first thing that we're going to review is foiling. Now we know that when we have x plus 3 quantity squared, I'm not just going to distribute that squared in to get x squared plus 9. That's actually x plus 3 quantity 2 times. So I've got a FOIL first, outer, inner, and last. Then I want to combine my like terms, and I notice that I have exactly the same two pieces in the middle, which is 3x and 3x, which gives us 6x plus 9. There is the shortcut when you are foiling pieces that are exactly the same. You square the first term, so x squared gives you your first term. Multiply the two pieces together, so x times 3x is 3x. But we have two of the exact same middle terms, so I take that 3x and I multiply by 2. I can go directly to my 6x. And then I square my second term, and 3 squared is 9. So the same thing is true for our next one. When I square this quantity, that means I have that quantity twice. We can use our shortcut. We can square the first term, multiply the two pieces together to get a negative 2x. But we have to double that because we have two of the exact same middle terms. So when we multiply those two terms together, I get a negative 2x, but I've got to double that to a negative 4x. And then we square that second piece. So a negative 2 times a negative 2 gives us a positive 4. Now that is foiling. The opposite of foiling is factoring. When we foil, we go from our factors to standard form. And when we factor, we go from standard form to our factors. So when we are factoring, we are looking for two numbers that multiply to the outside and add to the middle. So I'm going to break this up into its two factors. We see that we have a positive product and a positive sum. Therefore, we know that we've got a positive and a positive. And in this case, 4 times 4 is 16, and 4 plus 4 is 8. So when I factor, I realize that I have the exact same quantity 2 times. So instead of leaving it like that, I'm going to change it to x plus 4 quantity squared. And I want to make sure that I do combine it like this. That's the most simplified way to write it. Same thing for our next one. We are looking for two numbers that are going to multiply to the outside and add to the middle. And when we go to break this one down, we see that we have a positive product but a negative sum. The only way to get a positive product and a negative sum is to have two negative terms. And in this case, both those negative terms are a 9. So again, I see that I end up with the same two pieces, so I write x minus 9 quantity squared. And the very last thing that we're going to review is solving for an x squared. If we want to get x by itself, the opposite of squaring something is taking the square root. So I'm going to square root each side. And hopefully you remember that when we square root and we're solving for an x squared, we have to have that plus or minus in there. And we've got to break down our radical since 40 is not a perfect square. So we've got 2 and 20, 2 and 10, 2 and 5. We've got a pair of 2's. There's a 2 left over and there's a 5 left over. The pair goes to the outside, and the two numbers left over get multiplied together to give you a 10 on the inside. Alright, for our last review problem, we've got x squared is equal to a negative 50. Again, we want to get x by itself, so the opposite of squaring something is taking the square root. Just like before, 50 is not a perfect square, so we've got to break it down. 5 and 10, 5 and 2. We've got a pair of 5's with a 2 left over. The only difference with this one is the fact that I have a negative inside the square root. Hopefully you remember that I is equal to the square root of a negative 1. So we can now take square roots of negative numbers because we've got these imaginary components. So when I break this down, my answer, I've got the plus or minus because I was solving for an x squared. And because of the negative, I'm going to have an I on the outside. I'm going to bring that out with the pair of 5's. So I've got 5I with just the 2 left over on the inside. Alright, so let's get into our new material. First thing we're going to do is complete the square. In our review, when we factored both of our trinomials, they happen to be the same two factors. That is a perfect square trinomial. So what we're doing when we're completing the squares, we're trying to find the value of c, so this missing c value, that's going to allow us to have that perfect square trinomial so that when I factor it, I have the same two pieces. The way you do this is to take half of your middle term, and in this case half of 16 is 8, and then you square it, and 8 squared is 64. So that missing c value that we were trying to solve for is 64, which means that if I were to plug that in, my perfect square trinomial is x squared plus 16x plus 64. And if I were to factor that, two numbers that multiply to 64 add to 16, that's 8 and 8, which would be x plus 8 quantity squared. So everything's kind of tying together here. We're trying to complete the square to create that perfect square trinomial. So we're going to do the same thing with the next one. To find that c value that's going to give us that special case, we take half of the middle term, which is a -2, and then we square it. A negative times a negative is a positive 4. So in this case, our missing c value was 4. And when I plug that in, my perfect square trinomial is x squared minus 4x plus 4. Our next two, take half of the middle term. Now unfortunately this time it doesn't divide as nicely as the first two did. Do not write it as a fraction, do not write it as a decimal, keep it as a fraction. So I've got 5 halves, and then I square it. When you square this, you square the 5 to get 25, you square the 2 to get 4. So our missing c value, is 25 fourths. And we'll get into more about how to actually use that. But for right now, we're just trying to find that missing c value. Here we take half of our middle term, and we know that if we don't have a coefficient written, it's an assumed 1. So when I take half my b value and I square it, I end up with a positive 1/4. So to create a perfect square trinomial here, my missing c value was 1/4. So don't forget that these are written in standard form. So when we're talking about the b value and the c value, we are talking about the ax squared plus bx plus c. And we're trying to find that outside number by taking half of the b term, the middle number, and squaring it. Okay, let's turn to the back page. And we're going to use this completing the square idea to solve for a quadratic. Right now, what we know, the easiest way to solve a quadratic is by factoring. It's the least time intensive, and I think it's just the most familiar. So we always start with what would be easier. We don't want to make our life more complicated than it needs to be. So we're looking for two numbers that multiply to 12 and add to 12. So two factors of 12 are 1 and 12, but when I add them, I get 13, so that's not going to work. I've got 2 and 6, that's 8. We want a sum of 12. And 3 and 4, nope. So in this case, it's not factorable. Up until today, what we would do is just stop and say not factorable and maybe just move on. Well, now what we can do is we can solve this quadratic by using that completing the square idea. What we're going to do is we're going to create a perfect square trinomial. So what I need to do is isolate those two pieces. So I'm going to move the 12x over to the other side. And we are going to solve for that missing c value. And we've got a -12 on the other side. So we take half of our middle term, half of 12 is 6, and then I square that, and our missing c value is 36. Now you guys know that anytime we add something or multiply by something, we have to do it on both sides just to make sure that our equations stay in balance. So if I'm just going to create and add this 36 here, I have to add 36 on the other side as well. That way my equation stays in balance. Now that I've created the perfect square trinomial, I need to factor it. And so I'm looking for two numbers that multiply to 36 and add to 12. And we did that so that we knew it would work, and that number is 6 and 6. So I've got x plus 6 quantities squared. On the right hand side, I've got negative 12 and a positive 36, which is 24. Okay, so now what I want to do is I want to solve for x. We did this a few days ago. If I want to solve for x, I have to get rid of this squared symbol. So I square root both sides. The square root and the square cancel, so I've got x plus 6 is equal to plus or minus, because we square rooted something squared, and we've got to break down 24. 4 and 6, 2 and 2, 2 and 3. We've got a pair of 2's with a 2 and a 3 left over, so that's plus or minus 2 root 3. Now x is almost by itself. We subtract 6 from both sides, and we've got x is equal to a negative 6 plus or minus 2 root 3. Alright, so that's how we can solve for a quadratic when we can't factor it. So completing the square is one of those options. Alright, so what we want to do is we're going to use our calculator to check our solutions. So press pause and get out your calculators. Okay, we plugged our equation into our calculator, and we're going to graph it, so we press graph. Make sure that you do zoom 6. So we start off with a standard window, and I see that I've got to move my graph a little bit to the left and a little bit down. So I'm going to go to a negative 15 for the x, and let's go to a negative 20. We'll see if that does the trick. Alright, it doesn't move all the way down, but we don't need that. If I'm going to check this on my calculator, what I'm looking for is the x-intercepts. Your solutions are the x-intercepts on your graph. So right now, we've covered 3 different ways to solve for x. One is factoring, one is completing the square, and one is finding the x-intercept on your graph. So we go back to our y equals, make sure that we have a 0 and y2. Second trace, we want to find the intersection between those two, so that when we look at the graph, we have the first curve, second curve, we guess, and we find that our first intersection point there is at negative 1.10, 0. Second trace, find our second intersection point, first curve, second curve. We've got to make sure that we scroll over to that second x-intercept, or just give you the same one twice, and that's going to be at a negative 10.89 rounded up is 90. Okay, so we're going to double check our answers. That doesn't even look close to what we have, because what we have is an exact answer. These are rounded answers. So let's go to our home screen. Remember, we have 2 solutions here. One is a negative 6 plus 2 root 3, and our other one is negative 6 minus 2 root 3. So we plug in negative 6 plus 2 square root 3, enter. And it just so happens that the answer we found doesn't match our graph. So we made a mistake somewhere. Convenient that we check our answers to make sure that everything works out right. And if we look back, when we broke down our factor tree, we had a pair of 2's, and we had a 2 and a 3 left over. So this actually should have been 2 root 6 on the inside there. And when we make that correction, we change the 3 to a 6, and we get the negative 1.10. And then if we subtract our square root sign, we should end up with that negative 10.89 rounded up to 90. So make sure that you're always using all of your resources. Alright, let's go ahead and do another example. So what we're trying to do is create a perfect square trinomial, In order to do that, I'm going to isolate these by moving 3 over to the other side. So I've got x squared plus 10x, and I'm going to add in that piece to make the perfect square trinomial. And whatever I add to the left, I have to add to the right. Take half of your middle term, which is 5, and you square it. So that's what you're going to add to each side, is that 25. Now we've got to multiply to 25 and add to 10. And yes, that's x plus 5 and x plus 5, which means you've got x plus 5 quantity squared is equal to 3 plus 25, which is 28. Within the last two problems, you should have noticed that the number that you were squaring was the factor. That's always going to be true. Alright, so let's solve for x. We square root each side. Break down 28, 4 and 7, 2 and 2. So we've got x plus 5 is equal to plus or minus 2 root 7. Make sure we don't make any mistakes that time. Move the 5 over, and we've got x is equal to a negative 5 plus or minus 2 root 7. And I want you to go ahead and leave your answers in exact form. Don't round. Okay, we have one more left to do, so I want you to go ahead and press pause and try the last one on your own. Alright, let's check your work. We want to create that perfect square trinomial first, so we move the 4 over. Half the middle term, square it, get a 1. A negative 1 times negative 1 is a positive 1. We add 1 to each side. Then we factor that trinomial, which is x minus 1 quantity squared, square root each side. This time we had a negative inside the square root sign, so don't forget that that's I root 3, and plus or minus. Then we want to isolate x, so we move 1 over to get x is equal to plus or minus I root 3. And that's it for today.